Okay, so page 17. If we get through with this, then I'll have some additional problems that I can go through with you, and I'll have some scratch sheet up there, so you guys can grab that. Need it. All right, so number one says find the average value. So average value, go through average value theorem. One over b minus a, depth integral from a to b of f of x. But in this case, the function is f prime, so we just have to understand we're just talking about the region between the f prime graph and the x-axis. Okay. Let's make sure that we know what parts of the graph we're looking at between the graph and the x-axis. So you want to practice highlighting so that you're just looking at those regions and not anything else. So this one, we are going from -4 to 4. So we are going to use the entirety of our graph, but always pay attention to your interval, right? If your interval doesn't include the entirety of your graph, then make your adjustments. You're not going to count everything then if not all the values are used. Okay, what are our a and b values? -4. Yeah, so we just plug that in, right? Okay, so our attention is going to be on the depth integral, the area component. And then we just have to make sure we don't forget about that 1/8 at the end. So all these shapes are triangles and squares, or triangles and rectangles. Okay, so this portion is 1/2 base times height, but it's below the x-axis, so -1/2. Here, I'm just going to combine this here, this region, 1/2 base times height. This is all going to be -1. This is 1/2. This is 1. So these cancel out. 1/2, -1, and 1/2. These cancel out. So I'm just left with 1 plus 1, which is 2. Right? So in other words, what we're doing is we're trying to find the average height, right? So we kind of imagine where that average height is going to be. It'll be somewhere maybe between 0 and 1 if we were to take all the averages between all the negative and positive values. So, but is 2 our average height? Because we added these up. Or is there something else that needs to be done?
You need to plug in the 1/8.
Yeah. Yeah, so a lot of students forget about this. They do the area and they feel like, I mean, it is part of the process, but we're not trying to find the area, we're trying to find the average height. So, and also that 2 shouldn't make sense, right? The graph only goes as high as 1. The average height can't be as high as 2. So that seems a little high if we were to kind of think about it. Okay, so 1/8 times 2, which is 1/4. That feels better, right? That's the answer. And if you were to look at that, you know, if you were to compare all the heights of all the y values, that seems to be about right. Okay. Okay, it says find the average value on the interval from 0 to 2. Now we're just going to rely on the function here. So same formula, which is going to go through power rule instead of rating from a graph. 1 over b minus a. Okay. 1/2 in front. We're going to take care of the antiderivative first. Power rule, and then the balance can play a role. Okay. 4 becomes 4x. X squared becomes x cubed over 3. Okay, upper bound first. 2 goes in for both of the x's. And then the 0 is going to wipe the terms out. Okay, so I'll get 8 minus 8/3. Which is the same thing as okay, so 8 minus 8/3, common denominator, I get 24 over 3 minus 8/3, which is 16/3. This is the area component. Don't forget about the width component here, 1/2 times 16/3 equals 8/3. Okay, so this is my average height, average value. So part B saying find the C value guaranteed by the average value. So we're just now, this is our Y value. We know this is the average height, average Y value. Now just trying to figure out where on the graph does it actually hit this Y value of 8/3. So just plug it back into the function. Common denominator, 12/3. Take the square roots. Plus or minus shows up. Root 4 is 2 over root 3. These are two C values, but do we keep both of them? Just what? Because interval is showing from 0 to 2, just positive numbers. So my C is just, it's possible that we have more than one C value, but always check with your interval. You're guaranteed at least one, but more than one, it's possible that the second one could be left out. Okay, number 3. In-depth integral, x minus 2 over the 4th root of x squared minus 4x dx. First thing we always want to consider, can we expand our way through and just rely on power rule? Why not?
Radical.
Radical and what else? I mean, if it was radical with that, that's not an issue, right? So radical with
2 terms.
good, more than one term added or subtracted, right? This is too complicated for power rule to handle. Okay, so we know u substitution is going to be our next option. Let's get our parentheses to show up. Raised to the what? Okay. What's our u value?
X squared minus 4.
Mm-hmm. Okay, derivative du dx. So derivative.
X minus 4.
Okay, cross multiply. Okay, I'm going to make my substitutions now. Replace what I underlined with u. Replace dx with du over 2x minus 4. All right, we need the x to cancel out. These are not quite exactly the same thing, but maybe there's something that we can do to make these look more alike. Is there something else that I can do with this 2x minus 4?
Take up.
Yeah, what if I factor that 2 out? Yeah, so if I factor that 2 out, then I can get something that I can pair up and cancel out a little bit cleaner. So if I factor a 2 out, I get 2 parentheses x minus 2. Right? Do you see our x minus 2 is canceling out? Okay. But there's a leftover what? Okay, so 1/2 out in front. I mean, we would like to do power rule, but is there something else that needs to be adjusted before power rule can occur? What's needed?
Need to change the X.
Well, we want to apply power rule. This is power rule, but something is a little bit off. Bring you book. Yeah, the variable is in the denominator. I know it feels like we just do power rule here, but the variable in the denominator, power rule doesn't work. There's a different exponent in the denominator. It needs to be in the numerator before we can apply power rule. So I'm going to pull the 1/2 out, and I'm going to push that u up to the top, which is going to force my exponent to change. You're going to get a different answer if you did power rule here, which won't be correct. Power rule needs to be applied with the variable up top. Okay. All right, so now more straightforward now. Power rule, add 1 to the exponent divided by the new exponent. So u to the negative 1/4 becomes what? 3/4. Plus c. Okay, so here there are no bounds. So if there are no bounds, if it's an indefinite integral, then we have to make sure we include plus c. If there's a definite integral, no plus c, then we'll work the bounds in and get a number at the end. Yeah, we do. Mhm. But yeah, you're right. We got. I'm going to do things one at a time here. I'm going to try to resolve these messy fractions, and then yeah, the u has to go back in terms of x. Okay, so dividing by 3/4 is the same thing as 4/3. Sorry. So 4/6 reduces to be 2/3. And x comes back into our answer. We've pretty much taken care of, for near the end, just make sure that you bring back your x. Yeah.
Can you go over an even and odd problem?
I will, yeah. So once I get through this these 2 pages, I'll do an even odd. Yeah, so the signs that we can look for are these here. So yeah, if you have radical with multiple terms, that's indication that expansion can't work. If you have a parentheses with a messy exponent that is unmanageable, that's also use substitution.
I think greater than 2.
I'm sorry.
Exponent greater than 2, basically.
Yeah, exponent greater than 2, right? So let me show you an example of something that is, let me ask you about this one here. Can we do power rule expansion with this? Yes, okay. There's no issues with this. I mean, it takes a little bit of effort, but we can FOIL this out, distribute through. And there's only one term in the denominator. I mean, there's no plus or minus in between. These are multiplied, but they're still considered one term. We can expand it out and then split them up into individual fractions. Right?
Usually bring the next up to use that to it.
I prefer to do that later. If you bring the 2 up, then it's incorrect. I mean, you can bring it up as 1/2, but the way that I would do it is I would do, and once you expand all this out, split them up into individual fractions like this. Oops. Pull out the coefficients within each fraction, then bring up the exponent or subtract exponents from there. Yeah, I think the issue is when you bring the 2 up, you may forget that it's really times 1/2. And also, if you bring that x up to the top, you may forget to distribute through all the terms. Some students, they bring the x up and they only deal with the last term because they feel like that's the only thing that, but if you do it this way, then you're always reminding yourself, okay, my denominator is going to impact every numerator in my problem.
So either bring 1/2.
Yeah, 1/2 out for each, or I can reduce for each. This one will be 1/2 x to the 9/2. This can just already reduce, so 8/2 is 4. And then this can reduce. And then do a power rule here.
Variable the denominator doesn't necessarily mean that you have to use substitution.
Right. Only if there's multiple terms like this. Right. As soon as you see a plus or minus inside a square root, you know it's going to be a substitution. Okay, we're stuck. Yeah. Okay. Does that answer your question? About
Yeah.
Right, number 4, what's our strategy here? Definite integral involving absolute value. Draw the graph, create your triangles, add your 2 triangles. So first things first, let's figure out what our graph looks like. Absolute value of x plus 3. This is telling us that there is a vertex at x equals -3. Okay, the 2 triangles are not the same size, but we can just find the areas of them independently. So this graph, this V graph is this y equals absolute value of x plus 3.
So I get 2. That's 5.
Oh, I'm sorry, my bad. -5 to 2. Okay, so then we count our width. Our width here is 2. And if I plug 2 into the function, sorry, if I plug -5 into the function, because this is -5 here. -5 into the function. -5 plus 3 is -2. Absolute value of -2 is 2. 2 is the height as well. So width and height are both 2. Here, my width is 5. And then if I plug 2 into the function to get this location, this height will also, this y value is also the height of my second triangle. So 2 plus 3 is 5. Absolute value of 5 is 5. 1/2 base times height. And the second triangle, 1/2 base times height. Right, so you just look for the y value. So for instance, if I plug 2 into this function, I can get this location. And that location will also represent the height of my triangle. Okay, next page.
Some more with trig too.
With trig?
Like some more problems with trig.
Yeah. We'll definitely do some. All right, number 5. Number 5. Do we touch the bounds in the beginning? No. Okay, so bounds the last thing that we do, right? So rewrite the problem. Okay, so we're going to focus our attention on just between the integral and dx here. Can we distribute, expand our way through? Yeah, use substitution, right? Let's rewrite it so we can see our u value. What's our u value? Okay, what's the derivative? Cross multiply. All right, can our x's cancel out?
Yeah.
Yes. We can push out one in front. Okay, ready for power roll, right? Okay, let's clean up our fraction here. Divided by 3/2, same thing as multiplied by 2/3. All right, what's next?
The bounds, we have to change bounds.
Yeah, so okay, so there's two ways. My key, I changed the bounds and I use this expression because we can do u and u. But I'm going to do it another way from what the key is doing, which is replacing this in terms of x and then using the bounds. Okay, so it's up to you. The only thing we can't do is this. We can't use the u to 3/2 with the 0 and √7. That's wrong. Okay. So the key is showing one way. I'll show another way. I'm going to bring the x back into the problem here. No plus c, right? Any questions here at this point? Now, do you see how the bounds are out of order? It's okay. This is not an issue if you're just plugging values in. Now, if I'm trying to read the graph, I'm trying to interpret something with the graph, then I want my bounds from smaller to larger. I mean, if you want, you can change the bounds. You just have to make sure you pull a negative outside. But I just feel like that's additional work. Just leave the bounds alone and just plug in as you normally would. Okay. Everything will work out the way it's
Would it
supposed
still
to.
be -1/3 though?
There may be a -1/3 that shows up, but you know, whatever answer we get, that's the answer that we get. Right?
I mean, should it be a negative sign?
Oh yeah, you're right. Thank you. Okay, upper bound first. Minus. Then parentheses, there's another negative from the original 1/3. So 16 minus √7 squared, which is just 7. Okay, you can leave your answer unsimplified. There are no trig here. This is okay. You can leave your answer in this form and you'll get full credit. Yeah.
How do you know when to do like the second
Theorem.
theorem? Because like that's a radical. So then I was like, but don't you do it when there's like weird?
No, you do a second theorem when there is these opposite operations at the same time. If you see derivative and integral at the same time, talking about the same function, that's when you do second theorem. So second theorem says, you know, the second theorem says we can cancel out two operations and just plug something in, right? This is right. It's always asking about the derivative of an integral. Right? But here, there's no derivative. This is just integral. So this is just one process.
Would it become positive?
You mean to be flipping
Yeah.
the balance here?
Would the 1/3 become positive?
Yep, it'll be positive here, but then it'll be negative here. So it'll just be, these values will just be flip-flop. It'll still come out the same. It looks a little different, but the answer will still be the same. But yeah, if you want to flip the balance, just make sure you make that a positive 1/3 and then go through the process. Or changing the sign of the expression. All right, number 6, I want to change something about with number 6 here. I want to make it into a definite integral problem. So I'm going to put this on a separate sheet. Okay, first things first, we don't touch the balance, right? The balance is not going to do anything. All right, so at least not yet. All right, do we have a single rule that can handle this problem?
Yeah.
Too complicated, right? I mean, we have a cosine rule, we have a sine rule, but when they're multiplied, that's something else, right? This is nothing that a single rule can handle. So we got to look to use substitution. What would you do to make it easier to, or how would you rewrite this problem? Okay, what's our U value?
That's not it.
Yep. Du dx. That's right, yeah. Always make sure that you only look at what's inside the parentheses. If you start including what's outside the parentheses, that's going to throw everything off. Right, derivative. Okay, cross multiply. Okay, make our substitution. See where x's go away. Yes, that's a good sign, but there's a leftover -1.
Whatever's left over, you bring over to the left side of the integral.
I'm sorry?
So whatever's left over, you bring over to the left side.
Yeah, just make sure that it's only a number, right? We never, if it's a leftover x, we can't just pull that x out, but you can always pull a leftover number out in front. Okay. U to the 1/3. Now we're ready for a power rule, right? U to the 1/3 becomes. Yep.
Oh, you just.
Yeah, I just put a, yeah, you can put a -1 there. I'm just put a negative in front. Okay, I'm going to clean that up here. Dividing by 4/3, same thing as dividing by 3/4. Okay, we have our antiderivative. Tell me what we should do next. Okay, why can we not plug in the bounds at this stage? Mismatch, right? This is in terms of x, this is in terms of u. So we either convert this in terms of u, or we get this in terms of x and then use the original bounds. Yeah. I'm sorry?
Put the cosine of x in.
Yeah, that's right. I'm going to work it out that way. I think most students prefer that way. Okay, so now we have x antiderivative in terms of x. Our bounds is also in terms of x. Okay, upper bound first, right? Minus a -3/4. Okay, I evaluate my bounds. Can I leave my answer like this? No, we gotta keep going. One more step, okay? Once you can replace these in terms of trig ratios, then you can stop. All right, cosine of pi over 4 is over 2. Cosine of pi over 6. Over 2. Okay. So I'll accept this. AP exam will accept this as well, but they'll take off a point, and I'll take off a point too if we don't go far enough.
You simplify more if you wanted to.
You could. I would really suggest that, especially on the AP exam, don't try to simplify because you're spending additional time on something that you could be, if you're
Wrong.
right. Yeah, you could be making a mistake further, and also if something's already right, move on, right? You have a time crunch, so you want to start working on something else. They will, but you don't know exactly how their partial credit is going to work, right? I mean, they're all on the same page when they grade, but we don't know. Like, we don't know exactly as a test taker how they're assigning partial credit. So. Okay, let's do number 7.
Always upper bound minus upper bound.
That's right, always upper bound minus lower bound. Okay, first things first, can we distribute, expand our way through? No, we have two terms inside the radical that are being added, subtracted. Expansion is out. So use substitution. This is our next option.
It's a link in the circle before or no?
I'll give you a blank page, but you have to create your own unit circle. Yeah, same thing on AP exam. You won't get a blank unit circle there either.
Okay, so it's this one page with how you just there.
Yeah, I'll give you a scratch sheet.
Okay.
Okay, what's our U value? U dx equals cross multiply. Now dividing by -1 is the same thing as multiplying by -1, right? Right. I'm making my substitutions. Is there something getting in the way from moving forward with antiderivative?
That X.
The x needs to be resolved. The x is not canceling out. So if it's not canceling out, then our next option is, can we replace it with something in terms of u? Yeah. We can rearrange this equation, right? If I solve for x equals 1 minus u, right? Okay. Okay. Integral 1 minus u to the 1/2 times -1 du. I'm going to rearrange this so I can just distribute all at once. I'm going to make it -u to the 1/2 times 1 minus u. Okay, so we're not quite there yet, but at least we have a path towards power rule, right? If we can distribute this through and rely on power rule from here. Hmm? Yeah, I pulled, you can put a -1 here. I just put a -u. Yeah, it's up to you. I'm going to just leave the 1 out. Okay, so -u to the 1/2 plus what? Everything is nice and clean, right? Power rule here. What comes after this? Let's see. Let's flip all the complex fractional values up. Can we leave our answer like this? Bring back what? Yeah, so this, when we go through your substitution, u is only a temporary variable, right? Make sure you bring back your original variable, x. Okay, number 8. Okay, number 8, we want to find the derivative of a definite integral. We know that we got to apply what? Second theorem, right? So second fundamental theorem says I can plug the upper bound into the function, multiply it by the upper bound's derivative, minus, then plugging the lower bound, minus lower bound's derivative. Okay, so the root x gets plugged into the expression, into the variable of the expression, multiplied by the upper bound's derivative, root x, same thing as x to the 1/2. And if I find x to the 1/2 derivative is 1/2 x to the negative 1/2, minus, repeat the same process for the lower bound, because this is also a variable. If this was a constant, we can just let it drop out, but that's also a variable that's also going to get lodged into the expression. Negative 4x in for t, 1 minus negative 4x quantity squared, times my lower bound's derivative times negative 4.
Why leave it?
Yeah, you can leave it in this form. This is fine. Yeah, I don't simplify.
You don't have to show any steps, basically, it's great,
Right,
because there's not.
right. Yeah, if you can, yeah, I mean, this is your step right here.
Yeah.
This is showing all that you're applying second theorem. Okay, let me do an even and odd function. I'm going to skip number 9. I think we should be pretty good with that, right? Taking the antiderivative. You demonstrated that on the quiz. If you need scratch sheet, I have scratch sheet up there. Oh,
Think of it when you're doing also.
yeah, it's similar.
Basically, the most simplified form we can get just can have any trig in it.
Say it again.
Like you don't have to like simplify it all the way, it just can't have any trig in it.
That's right. That's right. That's right.
What page are you on?
Oh, this is a problem that I'm creating. That's not on your scratch sheet. That's not, sorry, that's not on your review. So you can just put on the scratch sheet or on a blank page. Okay, so first things first, we have to decide which one do we want to work with first. Which one do we want to apply first?
Smallest one, too.
So which one? This one, first one, or the second one here? Okay, I know you're looking at these numbers here. These numbers don't represent what we want to look for. We want to look for what? The shorter what?
Interval.
Short interval. Right, look at the shorter interval here. This is spanning out a larger width. This is the shorter width here. Okay. Now, something is a little bit off though about this in terms of representing what it should be looking like on the graph. What do you notice here? Right, this is not really a positive 3. This is really a negative 3 because the bounds are out of order. So we can rewrite the bounds, make it more straightforward. So anytime I swap the bounds, I can change the sign. Okay, so this is really what this is talking about. Okay, so let's create this graph here. So 2 to 4 is showing a negative 3. which means the other side must be what? Also what? Yeah. Okay, so make sure you take care of these before you do that last interval. So now let's look at the larger interval from -4 to 2. We don't want to do any overlapping, right? All we want to do is to fill out the missing space here. So we know that this is going to add up to be -2. We already have -3 here involved. What can I do with these two spaces to allow for this to be -2? So I'm missing a 1, right? I need -3 plus 1. I can split 1 across both spaces as what? 1/2.
Do that again?
So -3 plus what is equal to -2 plus 1. And I have to split 1 on either side because it's an even function. I got to create a mirror image. So this must be 1/2. This must be 1/2. Right. So when everything is said and done, our graph has to be mirror images.
So they all feel like.
Yeah. So now we can add up our region. Our region is from 0 to 4. So that gives us
Positive, positive 4. How do you get the -4, -2 coordinates?
oh, so we know that this is given to us, right? But if it's an even function, what has to happen on this side? It's got to be a mirror image, right? So even function, I got to have, so imagine that there is a dotted line here, right? And I'm folding my paper across that dotted line. And I have the graph, if it's an even function, the graph is going to be a mirror image on both sides. So if I have this side figured out, I know this side must also be the same thing because it's even. They're telling us it's even, so we can make that conclusion.
I know you had those two functions at the beginning. You just ignored the other one. You figure out which one's needed.
Say it again.
If you just ignore the other function, once you figure out which ones.
Well, we did use this one. We said the integral from -4 to 2 is equal to -2. So we have -1 plus 1 is equal to -2.
Okay.
But we don't want to. I know a lot of students want to do this. They want to do the full overlap between this region, but then you're negating then you're undoing what is done here, right? We can't put a region on top of another region. So just understand that the larger region is only telling you that the smaller regions will add up to that number.
Are you an odd one?
Yeah. Let me do a different one for odd.
Are you also able to just have integrals together and divide by 2, since the intervals from irregularity?
Yes, yeah, that should work too. Let me see. Okay, let me pull an odd function from page 9 here. Okay, so we want to find odd function. Given odd function, we have two intervals here. This is page 9, by the way. We start with what? So which one do we start with? Yeah, this one here, right? This one has a shorter interval, right?
You always start with shorter.
Yep, start with the shorter interval, yeah. So 0 to 3, this is in order, right, from smaller to larger, so this is good. No need to make any adjustment. All right, now we know it's an odd function. What can we say about the other side? Okay, so now we can think about the larger interval. The larger interval is just telling us what everything is going to add up to be because there's an overlap. So from -3 to 6, we know that all these smaller intervals must add up to be -4. So we just make a note of that. So these two regions, we don't want to add anything to this. This is already finished. We just have to figure out what this missing region is, -4. So if this is -4, can we say something else about the other side? Because opposite, yeah, odd function.
Also, odd function is always gonna be opposite.
Yeah, so odd function, a way to double check that your odd function is correct. You should be able to add up all the numbers from one end to the other. Yes, assuming that you're adding from the same distance from on the other side of 0. Yeah, it should add as be 0.
So how'd you know?
So we know that this full region must add up to be -4, right? -2 plus 2 is 0.
Oh,
So the only remaining thing to allow this to be true must be -4. Okay, so now we have to figure out the integral from 0 to 6. Just add up the numbers that we see here, which is 2.
this is for more practice.
Yeah. So even integral from 0 to 3 equals 2.
Also, you're gonna start with both no matter who's odd at the same point.
That's right. Yeah, the shorter interval is always the first thing, no matter whether it's even or odd. Okay, so now it's an even function. What can we say about the other side? So the region from -3 to 6 equals -4. We have 2 and 2 already established. This must be -8. Let's test it out. So 4 minus 8 is -4, so this one works. Now this side is -8. What can we say about the other side? Okay, and then so it says find the definite integral from -6.
-8.
Because we know that the region from -3 to 6 will add up to be -4. So I have 2 and 2 already established. So I need a -8 here for these numbers to add up to be -4. Right. What's 4 minus 8? -4. And now it's asking for the integral from -6 to 3. Yep, be -4.
Get out the lot.
Okay, good. So you did 4 minus 4 is 8, -8.
Yeah, I did -8 plus 2 plus 2.
Oh, initially, how do you -8? Yes.
So we know that this region, this is a larger region, right? This is telling us all the little regions must add up to be negative. So I put that off to the side. I know it's gonna add negative. Okay, now we have 2 and 2 established. So what must this region be in order for this to add up to -4?
Oh, okay, that was.
So a little bit of guess and check, right? So whatever number you put here, just make sure that these numbers happen to be this number that you know.
Yes. Besides that, and the one on the quiz reviews, do we just, are there any other questions on the test that we didn't cover this way?
Yeah, I think I covered everything. The only thing I cover is the.
No.
Now it's
Then
just.
like acceleration to velocity and succession.
That's kind of,
That's just like on the quiz, they get to go on the quiz.
that's right on the solve for the C values.
Mhm.
Have you solved for like the?
Yeah, so once you find the velocity function, we're gonna be given a ordinary at velocity level. Just plug that velocity function in, ordinary, solves the direction.
Are you gonna say the word velocity? Are you gonna say the word velocity acceleration, or are you just gonna use the same thing?
Yeah, it'll be, so let's say velocity acceleration, just like on the quiz review.
Well, this will be velocity.
It'll be more like. All right, guys, I need all your book bags up in the front.
I don't know, but it's, I've found it.
So,
Let you know.